Good day. Thanks for joining me. This is the Adobe Fikemba, and I told you in this channel, I will teach you physics, chemistry, and biology. I'd like you to, on the comment section, tap congratulations because this is chemistry. This is the last part of separation technique we're going to be looking at. So today we've learned physics, chemistry, we've learned physics and biology. Now we're looking at chemistry. So in chemistry, the last but not the least topic we'll be looking at is what? Separation technique, which is chromatography. So we'll be looking at separation technique. And in separation technique, we are looking at chromatography. Okay, I'd like you to follow me. Now, what is chromatography? Now, take note, chromatography is a separation technique that has to do with the separation of complex mixtures. Number one, it has to do with the separation of what? Complex mixtures. Okay? So when you are separating complex mixtures, you're carrying out chromatography. Another thing, again, you can see about chromatography is that it deals with separation of what? Colored. It deals with separation of colored and colorless substances. So when you are separating colored and colorless substances, you are also carrying out chromatography. Another thing again you observe in chromatography is that all the separation is based on the fact that once the solute is placed on an absorbent medium. Once the solute is placed on an absorbent medium, it migrates or moves at a different speed. So this is one principle, one process that takes place in chromatography used to separate complex mixtures or separating colored and colorless substances. And once this solute is placed on an absorbent medium, it migrates or moves at what? Different speed. Now, I want you to also know this, that there are two phases in chromatography. Quickly, two phases in chromatography. The first phase is called the what? The stationary phase. Okay, that's the first phase. The second phase is called the moving phase. Okay, the moving phase. These two phases are very important in chromatography. Now, I want you to know, what is the stationary phase? This is the phase in which the solute is absorbed. So I'm going to clean this out because I want you to see. So I don't want to go below or far away. So you can watch the video over and over to get what I'm writing. So the stationary phase, is the phase in which what? The solute is absorbed. Okay, this is the phase in which the solute is absorbed. Is that clear? Now, the moving phase is the phase in which the solute, the mixture dissolves. This solute, the mixture inside this solute dissolves and moves or migrates, at different speed. Don't forget, why this one is for the stationary phase, this is for the moving phase. Stationary phase, the solute is absorbed in the stationary phase. But in the moving phase, the mixture in this solute, they dissolve and move or migrate at different speed. Is that taken? So being able to look at the stationary phase and the moving phase. Another thing you need to know again in chromatography is when the stationary phase, is a solid, when the stationary phase is a solid, we call it, when it's a solid, we call it absorption chromatography. Okay, please take note. Once this stationary phase is a solid, this chromatography is called absorption chromatography. And the constituent, let me spell constituent for you, constituent, constituent. So I said, when the stationary phase is a solid, it is called an absorption chromatography. And the constituent of mixture, okay, the constituent of the mixture, okay, in this solute is separated by what we call distribution ratio. Distribution ratio, okay? Distribution what? Ratio. So the constituent of the mixture in this solute is separated by distribution ratio. What is distribution ratio? This is the ratio, okay, of the concentration of the solute in an organic solvent to the concentration of the solute in a what? In water. So that's why distribution ratio D will be equals to what? Will be equals to what? Concentration of the solute in what? An organic solvent to the what? Concentration. Are you seeing? Okay, good. To the concentration of the solute in what? In an aqueous, which is water. In water. Water is a solvent, universal solvent. Okay? So the distribution ratio will be used to separate the constituent in this absorption chromatography. Do you understand that? Now, if the solid is, the stationary phase is a liquid, when it is a liquid, if the stationary phase is a liquid, it is called what? It is called partition chromatography. Partition chromatography. It is called partition. Can you see that? I hope you can see. So it is called the liquid. When the stationary phase is a liquid, it is called partition chromatography. And to separate the constituent of mixtures in this partition chromatography, it is carried out using what we call coefficient of partition. Okay? Coefficient of what? Of partition. Is that taken? So don't forget, I told you chromatography has to do with the separation of complex mixtures, colored and colorless substances, and it's what is based on the principle of the fact that once it is the solute or the substance is placed on an absorbent medium, okay, it can move or migrate at different speed. And I told you there are two types, two phases in chromatography: stationary phase and the moving phase. Stationary phase is the phase in which the solute is absorbed. Moving phase is the phase in which the mixture dissolves and then migrate or move at different speed. And then I told you that if the stationary phase is a solid, we call it absorption chromatography. And the constituent of mixture in this solid phase is separated by what? Distribution ratio, which is the ratio of the concentration of the mixture or the solute in an organic solvent to the concentration of in water. That's the concentration of the solute in water. Then I told you if it's a liquid, it is called partition chromatography. And it is separated, the mixture, the constituent of the mixture is separated using coefficient of partition. So let me show you, okay, let me give you examples of chromatography. Okay, examples of chromatography. Number one example of chromatography, we have paper chromatography. Okay. We have paper what? Chromatography. That's an example of chromatography. And this is G. Paper chromatography. Number two, we have thin layer. Thin layer what? Chromatography. Number three, we have what we call column gas chromatography. Column gas what? Chromatography. Number four, we have what we call ion exchange what? Chromatography. So these four examples give you what chromatography look like. Now let me draw something for you. What processes involved that takes place during this chromatography? Now look at this now. This is what a paper chromatography will look like. Follow me. This is what a paper chromatography will look like. This is what it will look like. So around this area and here, this side is called lead. Okay, this is solvent. Then here you have something here which represents the solute. This is also solvent, okay? Represent the solute, but this place we call it spots, okay? The spot on the paper chromatography. Why this one is what? Paper chromatography, as the case may be. So this is what it looks like. Do you understand it now? Then also let me give you a formula that has to do with the relationship between how this what's it called? The solute, the complex mixture, they separate and they move. When the mixture begin to move, they migrate. So I want to give you the rate of migration. The rate at which this solute, the mixtures from this solute, migrate at different speed. So what that will be is rate of migration will be equals to what? Will be equals to the distance moved by solutes over distance moved by solvent. Okay, so the distance moved by solute. So from this place here now, here to this point here, will represent the distance moved by what? Solvent. Why? If you have the complex mixture separated from this solute now, you have something here, you have another one here. Then from here to here will be distance moved by the what? Solute in this solvent, in this paper chromatography. Do you understand that? Let's take for example now, let's solve this now. So let's say we have a complex mixture to separate, and then we have it in a what? In a solvent. So this is a solvent. Okay, so we have, this is the original what? The original solute. Then we have this solute being separated here first like this, and then another one here migrating at different speed, separated this part. So from this point here, they told us the distance from this solvent to this solvent is 30 cm. Are you with me? 30 cm. And from here, this one will take this as P. From here to this point, that's the distance from this original solute, the original position where this guy is moving out from. This guy came out from this solute. This is a mixture. These are mixtures separated from this solute itself. It's moving, and here we have 10 cm. And then the distance from P to Q is what? That's from here down to this. The distance from this to this is 5 cm. So they say we should calculate the what? Rate of migrating. So the question now is calculate the rate of migration in the paper chromatography. In the paper chromatography. So they say we should calculate the rate of migration in paper chromatography of P and Q. So what do we do here? What do we do here? Write out the formula. What's the formula? This, I gave you the formula. Look at it. Rate of migration is equals to distance moved by solute, which will be equals to A, to distance moved by solvent over B. So A over B. So now in this case, now they say we should calculate for P and what? And for what? What I need to do is rate of migrative A, P. They say we should calculate for P and Q. What do we have? What's the distance of the solute from this place to this to P is 10. So you now say 10 cm. It does not have unit. What's the distance of the solvent from this place to this place is 30 over 30 cm. So what do you have? 0, 0. Is that also 1 over 3? So what will 1 over 3 be? So this is 1, this is 3. I think that should be 0.33 something. Okay? Yes. 3 here, 0, 0. Bring 1 down. 3, 1, decimal. 3 times decimal, 0. Bring this one, add 0. 3, 0, 3. 3 times 3, 9. The same thing. So I'm correct. 0.33. Do you see it now? Then look at it now. So we've gotten for the rate of migrative of P. The rate of migrative of P is what? 0.33. Now let's look at the rate of migrative of what's the other one? Of Q. Rate of migrative of Q will now be equals to, now pay attention to this. If you look at, this is the original position where this thing was separated into this and into this. So therefore, if you're going to be getting the rate of migration of Q, it will have to be 15. 10 plus what? 5 all over what? 30. Why am I adding the 10? This is because from this place, originally to this place, it would have been naturally 15. But because this one, it took this one at this distance to separate here, then from here there was another separation, distance from here to here. So this one began to move at this. I don't know whether you understand what I'm saying. So you add, what you do is that, immediately the separation happened. Put it this way, immediately the separation happened, it gave us a distance of 10 from the original position to point P. And then from here to this place, you are supposed to add what separation took place between this and this. You are supposed to add it, because if you want, this Q is ahead of this one. So that is the original position from Q to this will now be what? 15, meaning you add 5 plus 10. That's why we did that. So what do I have? It will now be 15 over 30. Cancel 15 year 1, 15 year 2. So rate of migrating for Q, rate of migrating for Q will be 0.5. Yes, I think I'm correct. Yes, 1, 2, 2 in 1. That's 0, 0. Bring 1 down, 1 decimal again, and then you put 2 times decimal 10, 1, 0, add 5. 2 times 5, 10. So 0.5. So you can see rate of migrative of what? Of P is 0.33, because it was direct to this point. But if you watch, this is taken from this point to this point. I hope you're seeing what I'm doing now. So that is the reason why we have what we are having. Rate of migrative of P, it will be 0.33, and that of Q will be 0.5. So with this, we've come to the end. We've come to the end of separation technique in chemistry. Go to the comment section and type congratulations. I'd like you to follow from, this is part 10 in chemistry. I'd like you to follow from part 1 to part 10, and so that you can get a good breakdown of all the information. Follow me if you are not following me. I want to ask you a question now. Now, during centrifugation, I will ask you 3 questions. During centrifugation, the aqueous solution that is found during centrifugation, the aqueous solution that is found at the topmost parts, okay, of the tube, what do we call it? And the solid substance found at the bottom, okay, what do we call it? That's question number 1. Question number 2, we talked about, if I'm not mistaken, about 13 or 14 separation technique, as the case may be. Okay, now tell me, among these numbers of separation technique that I've explained to you, which of them, are you with me, is a chemical change type of separation technique? Which of them is a chemical, not a physical change, but a chemical change type of, you know, when you talk about separation, it has to do with a kind of physical change, because the reaction is always reversible. Which among all the separation technique I've explained, that will be what? Irreversible, or will be a chemical change, as the case may be. And I want you to tell me, what is the name? That's number 2. Number 3, what is the name of the solution, okay, name of a solution that have 2 mixable liquid? That's a kind of, you are separating a solution with 2 mixable liquid with constant boiling point. When the mixable liquid, okay, they are mixable, but they have this constant boiling point. How do you separate them, or what kind of a separation do you call that? What's the name of that kind of a solution that has 2 mixable liquid with constant what? Boiling point. See you in the next video. Thank you. Follow me if you're not following me. Thank you.